विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
Joining us is Dr. Pralay, a scientist whose work stands at the intersection of chemistry, physics, and environmental urgency. Since 2016, Dr. Shatra has been leading a research group dedicated to developing materials that can power our world sustainably. From the labs of IISc Bangalore to research positions at Stanford, Notre Dame, and Uppsala University, his journey has been global, impactful, and deeply rooted in curiosity.
I am Pralay Shatra. So I am a scientist at Center for Nano and Soft Matter Sciences, and I'm here in the center since 2016. So I did my PhD from Indian Institute of Science, Bangalore, and there I primarily worked on quantum dots. And then I was at University of Notre Dame for 2 years, where I was pursuing my postdoctoral research, and then I was at Stanford Chemical Engineering Department for 2.5 years, and then I also spent 1 year at Uppsala University in Sweden before joining this institute. So most of my work, what involves with different various studies based on nanomaterials, particularly semiconducting nanomaterials. So what we do is basically we are studying structure property relationship of different semiconducting nanomaterials. So when you consider a semiconductor nanomaterial and then you make it really small in size, particularly when it goes below its Bohr excitronic radius, it's a certain size. For different material, different compositions, it is different. Then it shows size dependent property. Like for example, this shirt is black, correct? It's because of dye. If we change the molecule, then only the color will be different. But when you take this material and the same material but different sizes, then the color changes. That is because of its optoelectronic properties are changing. Okay, so we try to synthesize different types of these semiconductors and then how these properties are changing. And then not only that, see for example, we have this material which are being used for LEDs, light emitting diodes. Okay, and then when you consider a light emitting diode, how bright that material luminescence, correct? So we do the modifications, or we look at different methodologies which basically enhance the luminescence. And not only that, we try to understand from structure property correlationship that why this enhancement is happening. Okay, so that gives us a way to strategize new formula to how to improve their properties. So that is overall what we are aiming for, and we use various type of spectroscopy, sophisticated spectroscopic techniques to understand this structure property correlation.
Okay, so basically mostly you specializes in like semiconductor, as you said.
Semiconducting nanomaterials. That is what we are primarily doing.
So can you tell us like where it is used the most?
So for example,
For the layman should understand what
yeah.
It is not for the research.
Correct.
The program's motto is to connect the scientist to the layman,
Yeah.
to the public.
Exactly. Yeah. So for example, the nanomaterials what we are talking about, it can be used for example in, as I was telling, light emitting devices. Since the discovery of LED, okay, then we see a huge improvement in saving electricity. So that saves electricity. So it's an energy efficient device, correct? Then these nanomaterials have very large surface area. So these are also being used at different catalysis. Okay, and the semiconducting nanomaterials, what they do there is basically they absorb the sunlight So when they are absorbing the sunlight, that means some energy it is harvesting, correct? And then we can harvest this energy, we can use this energy for various applications. Okay, like for example, these materials are being used for photovoltaics or solar cells, correct? So on the rooftop we see primarily today silicon based material, but people are looking for other materials which can replace silicon, okay, or which can perform better than silicon. So that is one application in directly with related to energy. And then catalyst, we are also trying to explore these type of nanomaterials for healthcare diagnosis. That is also one field of our research we are exploring. So I was kind of when I joined integrated PhD program at IISc, that is back in 2003 after my bachelor's. That time I first came across this research environment. From that time onwards, somehow I was motivated to research, do independent research, or carry this academic life, academic research area. Because the group where I was, it was highly motivated. I felt very motivated. I was very excited. So that is how it was. Probably that passion was there always since I got introduced into this field. So that's how, and then meeting different scientists all throughout the world, seeing their work culture, and how also what it matters is that maybe sometimes we are doing fundamental research, but the outcome of this research are directly helping our human society. So that is another big passion to continue this type of research, independent research. So although we are trying to understand fundamental research, but overarching goal is to how these materials, whatever we are developing, can be helpful for the human society. Of course, overall for our country as well, focusing on our country's need. So this field is very vast, so I can give my opinion or what I understand from the field I work. Okay, so there was a program started by government in India, Nano Mission. Okay, so that through that program, a lot of funding had come to different universities and different institutes. So that kind of helped in lot of research on material developments. So lot of now Indian researchers, they're capable of making lot of different types of nanomaterials, different complex heterostructures, etc., which shows these exciting properties and can be useful for different applications. But at the same time, there are a lot of things to be done. So yeah, it's an exciting field ahead of us. So any suggestions on how? See, for example, we need to choose the right problem. Okay. A right problem which is probably more specific to our country's immediate need. But at the same time, we choose our problem where the whole world is interested. So it's a multiple things. It's how where the interest is throughout the world, what is our country's need, what is the funding situation. All these together actually matters, and what are our student interest. So those things also matters. Yeah.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की